Hi, welcome back to Engage New York Module 4, Lesson 24. This is problem set and concept development all together. So we're going to work through these problems. Now, up until now, 24 lessons, you've been working on so many skills. And right here in this problem set, we are putting those skills together. We are going to multiply and divide, multiply using fraction and decimal multiplication. We're using fraction and decimal multiplication. Those two are our big ideas in this up to this point in this module. So how should we get started? So when we attack a word problem, you always want to ask yourself a few questions before beginning the first problem or any other problems. Number one, can you draw something? What can you draw? What conclusions can you make from your drawing? So that is our big idea here as we go through these problems. What can you draw? Well, first, can you draw something? What should you draw? And what conclusions can you make based on your drawing? That's where we're going here. Our first problem is a vial contains 20 millimeters of medicine. If each dose is 1/8 of the vial, how many milliliters is in each dose? So you've been working on multiplying a fraction by a whole number for so many lessons. You are so good at this now. FYI, a problem like this will be on the final exam, but they're going to take it up a few notches. You're going to be there are going to be several, like maybe 4 different operations that you're going to be using within this one problem. And each one of those solutions is an answer. So first, a vial contains 20 milliliters of medicine. So think about that. You see that on TV all the time in commercials and maybe in the news where they're using a syringe and they're pulling out a little bit of medicine to give someone a shot. So a vial is that little container that holds the medicine. So a vial contains 20 milliliters of medicine. If each dose is 1/8 of a vial, so in 20 milliliters of medicine, there are 8 doses in each vial. So in this vial, there are 8 doses to be administered. So our question is, how many milliliters is in each dose? So let's break that up. 1, 2, 3, 4, 5, 6, 7, 8. So we're trying to figure out what 1/8 of 20 milliliters is, right? Well, you've been multiplying what is of, right? So what is 1/8 of 20 milliliters? That's what you're trying to solve. Well, you know what to do. 1/8 times 20 is equal to 20 over 8. How many times will 8 go into 20? What do you think? 2, right? 2 will give us 16, and there'll be 4/8 left over, right? Well, 4/8, are we going to really leave it 4/8? Or we're going to go 2.5 milliliters? But wait a minute, let's go back to what the question is asking you. How many milliliters is in each dose? Okay, so 2.5 milliliters in each dose. Express your answer as a decimal. So now we need to express 2.5 milliliters as a decimal. So what is 2.5 milliliters? 2.5 milliliters in each dose. Okay, so that's your answer, not that, right? Okay, I don't think that was too difficult. I think everyone watching this video who has been going through Module 4, I think you can do that successfully. Here we go. Next problem. A container holds 0.7 liters of oil and vinegar, so not a complete liter, only 0.7, 70% of a liter, right? So 3/4 of the mixture is vinegar. So how many liters of vinegar are in the container? Express your answer as both a fraction and a decimal. All right. Can we draw something? What can we draw? Well, we could simply make a tape diagram if we wanted, right? And it says 3/4. So what are we going to divide this into? 3/4. And we know 3/4 is vinegar, right? And we know this whole thing is equal to 0.7 liters. All right, so what should we find out now? What are we trying to find? Well, we're trying to find 3/4 of 0.7 liters. Okay, we have a fraction and a decimal right now. What should we do? What would make this problem a lot easier? How about if we keep our fraction, and we know this is 7/10, right? So how about if we change our decimal into a fraction and change it into 7/10? All right, so we end up with 21/40 of a liter, right? So we expressed it in a fraction. Here is our fraction. Now let's take our 21/40 of a liter and change that into a decimal. So wait a minute, what do we know? Whoops. What do we know about converting it into that decimal? What are we always looking for? Tens, hundreds, or thousands, right? So could we easily multiply by, what could we easily multiply 40 by to either get 10, 100, or 1,000? How about if we multiply 25 over 25, and we're going to end up getting 525 over 1,000, which relates to 0.525 of a liter, right? So there are 21/40 of a liter, or 0.525 hundredths of a liter of vinegar in the container. Okay, so which part here would have been the challenge for you? Would it have been thinking about how you're going to take this fraction and turn it into a decimal? So did you remember, always look for that 10, 100, or 1,000. Take your fraction and you're going to multiply it by a number that's going to either give you 10, 100, or 1,000. Now you're not going to multiply anything by 40 to get 100. So I had to go up to try to get to 1,000. That's why I chose 1,000. All right, moving on. Our next problem Andreas completed a 5-kilometer race in 13.5 minutes. His sister's time was 1.5 times longer. So the same amount plus an extra half, right? So than his time. So when you think about that, it's his time plus a half, right? How long in minutes did it take his sister to run the race? So what do we know? We know that Andreas he ran a 5-kilometer race in 13.5 minutes. That's what we know, right? And we know his sister ran it in the same amount of time plus a half more. So 13.5 plus a half more. So how are we going to find out that half? Well, you could always start off by going 2 divide by 13.5 and find that half. Well, 2 goes into 13 6 times. So when you're dividing by a decimal, you leave the decimal there. And if there's no decimal out here, if this is just a whole number, you're going to move that decimal straight up to the top of the bar. Going to bring down the 5. 2 goes into 15 7 times. Subtract. Now I'm going to add a 0 to bring it down and zero it out. 6.5. So 6.5 what? Minutes, right? So Andres completed a 5-kilometer race in 13.5 minutes. His sister's time was 1.5 times longer than his time. How long in minutes did it take his sister to run the race? So simply 13.5 plus what? 6.75 minutes. Always add the 0 and fill in the problem. So we're going to add this. 6, 7, 8, 9, 10. 20.25 minutes. She ran, it took him 13.5 minutes, but it took her 20.5 minutes to run the same race. All right, there are multiple ways to solve this problem. I just took the easiest route. You could have done a few different ways to solve this problem. However it makes the most sense to your brain is how you should solve this problem. So if this is not how you would have attempted this problem, as long as it is mathematically sound and you end up with 20.25 minutes, what you did is perfectly perfect. Your choice or your approach, as long as it is mathematically sound, is perfectly acceptable. All right, problem 4, I'm going to skip. I feel like it's quite advanced and I think it takes us to a whole nother level. So we're going to skip problem 4 in this video and go straight to problem 5. There are 3/4 as many boys as girls in a class of 5th graders. If there are 35 students in the class, how many are girls? Okay, I think a problem like this is going to be on the end of the topic or end of the unit test as well. So this is a problem that we need to get good at. All right, how are we going to start? What can we draw? Is there anything we can draw? What can we draw? And what are we going to gain from that drawing? All right, so we know we're trying to find how many girls, right? How many girls are in this class? And there are 3/4 as many boys as girls. So there's more girls than boys because there's 3/4 boys than girls, right? Now, watch as I go through this. How many units are we trying to solve for altogether? How many units do we have here? We actually have 7 units, right? All right, watch where I go from here. 7 units is equal to how many students? 35 students, right? So going back to what we know, if 1 unit is equal to what? 35. 5, right? 5 students. So 1 unit is equal to 5 students. So if this is 5, 5, 5, 5, 5, 5, 5, does that make sense? Is that mathematically sound? So let's go back. If there are 35 students in the class, how many are girls? Well, there are 20 girls in the class, and there are 15 boys. Not that they asked us, but we know because there are 3/4 are boys and 4/4 are girls. And 20 plus 15 equals what? 35 students. So we know we ended up in the right spot. All right. We are moving down to a more advanced problem 6, but I think it's doable because you can draw a picture like what we've been doing here in order to make sense of this problem. All right, Ciro purchased a concert ticket for $56. The cost of the ticket was 4/5 the cost of his dinner. 4/5 the cost of his dinner. We don't know anything about the dinner right now. We just know it's 4/5 the cost of his dinner. The cost of the ticket is 4/5 of his dinner. The cost of his hotel was 2 times as much as his ticket. Okay, 2 times as much. How much did Ciro spend all together for the concert ticket, hotel, and dinner? Okay, what can we draw out? Well, we know the ticket, right? Equaled $56, right? We're not sure about dinner though, but we know the ticket was 4/5 the cost of his dinner. Right? So let's go dinner here. And what do we know about the dinner? The dinner is going to be more than the ticket because the ticket is only 4/5. So 1, 2, 3, 4. And what are we going to cut this one up into? 5, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Whoops. Let's get rid of one of these. Okay. It should be bigger, and I'm sorry I didn't divide it up quite nicely. So the the ticket fits inside the dinner, right? Because it's only 4/5 as much as dinner. We don't know. We need to find the price of how much that dinner is. Now, the hotel is 2.5 times the cost of the ticket. So here's the cost of the ticket, 1, 2.5. So if the ticket costs $56 and a half, What is half of 56? So 2 go into 56. 2 is 4. Is $28, right? So how much did this cost altogether? Well, 56 plus 56 plus 28, that's going to give us the cost for the hotel, right? So 6 plus 6 is 12 plus 8 is 20. 10, 11, 12, 13, 14. $140, right? Now, we're still missing the cost of that dinner. Well, let's go back to what we know about the 4 units. 1, 2, 3, 4. 4 units is equal to $56, right? And if, what would 1 unit be? So 4 into 56 is $14. That's how we solve the problem here. This is 14, this is 14, this is 14, this is 14. Then this is 14, 14, 14. It's all 14. All right, so what's 14 times 5? 20. That's $70. So we found out the total cost of the ticket, the hotel, and the dinner. It wasn't until we had to find out the cost of the dinner that we had to go back to the units. There are 4 units equaled $56, and I'm trying to figure out how much each unit is worth. And if I can find out how much each unit is worth, I know I can use that same number in with dinner. So how much, but the answer says, the question asks, how much did Ciro spend all together for the concert ticket, hotel, and dinner? So we need to add 140 plus 70 plus 56, and we get 11, 12, 13, 14, 15, 16, $266. So is this the answer? No. The answer is Ciro spent $266 all together. That is the answer. All right, hopefully that didn't go too fast for you. If it did, go back and review the video and know that what I've done in this lesson is basically what you need to know. These are the types of questions that are going to be on the end of the topic, the end of the module test. Now, in lesson 25, we're going to start switching gears. We're going to divide. We're going to start dividing a whole number by a unit fraction. So we've done multiplication up to this point, multiplying with decimals and fractions. Starting in lesson 25, we're going to move on to division, dividing a whole number by a unit fraction. All right, I'm sure you're ready to take on that homework. Good luck.